Once we've separated our crude oil into fractions, we sometimes process some of the fractions by cracking them, and we're going to look at what that means today. So here's my fractional distillation tower. You'll remember that we separate crude oil out into different fractions with boiling points ranging from at the top of the tower, really low boiling points, things which are gases at room temperature, and down at the bottom we have things which are solid at room temperature, like bitumen for road surfacing, etc. Just a little bit of background information here. When you put crude oil through fractional distillation, you get pretty much the same amount of product coming out of each of these pipes. It can change depending on where you're drilling the oil from in the earth. There are different types of crude oil that you get from different places, and so the proportion of stuff at the top and stuff at the bottom does vary a little bit, but generally speaking, you get more or less the same sort of quantities out of each pipe. And the problem with that is that actually we have a high demand for the stuff at the top with the low boiling points, and a low demand for the stuff at the bottom. And here's why. If you have a look in the UK, these are the latest figures I could get. If you look at the number of cars there, 32.5 million cars, and I use about 50 litres of petrol every fortnight, we have 19,590 aircraft registered in the UK. That's registered in the UK. That's not including the ones that fly in from other places and back out again. And we have 500,000, makes no difference, HGVs on the road, which are registered in the UK. Again, that's not including the ones that come here on ferries, and some of ours that are registered in the UK are going to be on the continent. They'll have been ferried out again. But that's the figures for cars, aircraft, and HGVs, which of course use the petroleum fraction, the gasoline fraction that is, or the diesel fraction, or the kerosene fraction for the aircraft. And those are all in this high demand section, and that's why there are quite a few of these. Now, if we look at the low demand, what do we use that for? We use that for lubricating oil and ships, and there are 1,306 ships registered in the UK as of 2018. Now, that seems like a very, very small number, so I'm assuming here that it doesn't include tiny, tiny boats. I think we're talking large ships, container ships and that sort of size ship here. But nonetheless, that's a much smaller number than cars, aircraft, HGVs, and things like that. And that's reflected in the amount of fuel that we use. So have a look at the amount of petrol. That's megatons, that's million tons, okay? So 11.6 million tons of petrol is used in the UK every year, and 12.3 million tons of jet fuel, kerosene, is used per year, and diesel, 24 million tons in cars and HGVs, heavy goods vehicles, and trucks, vans, all sorts of things. So you can see that that's huge amounts of the fractions in the high demand part of our column at the top. They burn well, they're flammable, they produce plenty of energy when they burn, but they're also volatile, so they're easy to evaporate, easy to burn, easy to get combusted. Down at the bottom, we use apparently 0.36 million tons of lubricating oil for all of this machinery. This is the lubrication. This is to stop things getting too hot with friction. This is the oil that you put in the car, for example, and on your bike chains, etc. That's all included in this. And that's a tiny amount compared to the petrol, kerosene, and diesel, isn't it? And the fuel oil, this is for shipping. And these are government statistics. You can go and look them up on the website. These are all from 2018, these ones, the quantities. Again, 0.8 million tons, so not even a million tons of fuel is used for shipping in the UK in 2018 anyway. So you can see that there's an awful lot more petrol, kerosene, and diesel being used. So we're producing more or less the same amount of lubricating oil and fuel oil and bitumen as we are of petrol, kerosene, and diesel. And what the point of cracking is we're going to try and turn some of the low demand fractions into high demand fractions, because they're more valuable, they're more useful, and we can sell them off much more easily. So shorter chain alkanes are more useful than longer chain alkanes, and therefore there is more demand for shorter alkanes. So cracking, what's cracking? Cracking is if we take a long chain hydrocarbon, such as the one I've got here, and we're going to heat it to 300 degrees C or higher, high temperature, and we're going to put it over some sort of catalyst. Now that could be aluminium oxide, or it could be porous clay, fired clay. It doesn't really matter, but 300 degrees C or high temperature is going to give a thermal decomposition reaction, which thermal means heat, decomposition means breaking down. So we're going to take this chain, we're going to break it up using heat, and this is what sort of thing that we might get. We might get a variety of products here, or we might just get two. In reality, we get a huge mixture of different things. So let's have a look in a bit more detail. Here are some equations for what you might get if you put C20H42 in. You can see that there are various different chemicals we can get out. We've got decane there, C10H22, and we've got decene, C10H20. Okay, and we could get dodecane, C12H26, and we could get octene, C8H16. We could get octane, C8H18, and we can get dodecene, which is C12H24. In fact, we can get an awful lot of different things out, and after we've done cracking, usually what we have to do is we have to put them back into fractional distillation to separate all these different chemicals out. But the important thing is that whatever we've put in a long alkane, and we're making it shorter. We're making a shorter alkane, and we're always going to get some sort of alkene out as well.